Hello and welcome to our teacher edition of the Truth in 10 presentation. My name is Sunfreezer Mora. I'm a climate reality leader trained in the April 2021 session, and the presentation I'm about to give you is a version of Al Gore's Truth in 10 presentation. Our committee made additions to it to include some useful information specific to New Jersey teachers, but for the most part it really is simply a good introductory presentation for anybody who is interested in learning more about climate change but does not have much background experience. So, without further ado, whenever we give this presentation, we like to start with this photograph. This was the first full photo of our planet that humanity ever saw. It's called Blue Marble, and it was taken in 1972 on the Apollo 17 mission. And it really changed the way that humanity saw our planet. From the ground, obviously, it looks very large and very much like we are separated. But this photo demonstrates how we really do all inhabit the same small and fragile bubble. Now, to get a little bit more down to earth, for the purposes of action, no pun intended, climate change can be broken down into three essential questions. And these questions are what we're going to be answering here today. The first one is, must we change? Secondly, can we change? And then finally, will we change? And for teachers, will we be able to teach for that change? So, first question, must we change? The answer is unequivocally yes. Scientists have been telling us this for decades, and now our actual planet, the atmosphere around us, and the ground and the sea beneath us are telling us this too. So, here is another photo of Earth from space. Last one, I think. And this is a photo from the International Space Station of the sun rising over the Earth's horizon. As we see from the ground, the sky looks vast and limitless. However, in comparison to the rest of the planet, as this photo demonstrates, it is little more than an eggshell, protecting us from the vacuum of space. But we are really not treating it like an eggshell. We are spewing 152 million tons of man-made global warming pollution, or greenhouse gases, into the thin shell of our atmosphere every 24 hours, as if it were an open sewer. That pollution, particularly carbon dioxide, is building up and it's trapping heat. Here is the basic science behind global warming. You all probably know this, have seen it somewhere or another. It's pretty basic science and we've understood it since the 1800s, but I'm going to run through it very quickly anyway. We know that solar radiation in the form of light waves passes through the planet's atmosphere where it hits the planet and is absorbed, warming us. Some of this energy, when it hits certain surfaces, especially things like glaciers and ice caps, is radiated back out into space in the form of infrared waves, releasing some of this heat, but on its way out, some of this radiation is trapped by specific gases, greenhouse gases, in the Earth's atmosphere, warming it further. So it stands to reason that when these greenhouse gas concentrations, specifically carbon dioxide concentrations, increase, more of that outgoing radiation is trapped, and this kicks off a series of effects that we call global warming. Carbon dioxide levels can increase due to a variety of reasons, and they have increased before in Earth's history. This can be because of volcanic eruptions, because of actually climate cool downs. When you have a cooler, drier climate, you often have deforestation, so less trees pulling carbon dioxide out of the atmosphere. But today we call modern climate change anthropogenic climate change because the rise in greenhouse gases today is because of human activities, and countless different things such as industrial agriculture, oil production, different industrial processes are all releasing greenhouse gases into the atmosphere as a result of our activity. But the biggest source of greenhouse gases today is the burning of fossil fuels. Fossil fuels are incredibly important, as I'm sure you all know, to our society. They supply over 80% of our energy, though as you can see on the edge of this graph here, there has been a slight leveling off as renewable energy and nuclear energy do gain more popularity around the world. However, they still are being burned at very high rates, and resulting climate change is manifesting across the globe in countless, generally harmful ways. The first and most obvious of these ways is just an increase in global surface temperature. So as you can see, in the last 4 decades, we have seen a huge spike in the average temperature that we're experiencing every year, which is far departed from what we had just over a century ago. In fact, 19 of the 20, and actually this should say 20 of the 20 hottest years on record have occurred since the year 2001. So 2020 actually tied with 2016 at the top of this chart for the hottest year on record, though it is not on this chart. And though heat may not seem like a very serious thing, heat-related illness is actually the #1 people die in connection to climate change. Climate change is connected to as many as 1 in 4 heat-related deaths, according to the New York Times, and heat stroke is very serious, especially when you live in more urban communities. Along with just the atmosphere rising in temperature, our oceans are also getting hotter. Oceans absorb 90% of the atmosphere's excess heat, and so their temperatures have also risen dramatically as the rest of the planet does. As you can see here, 50% of the rise in oceans, because they do warm a little bit slower, has occurred in just the last 20 years, and it is getting worse. So hotter oceans generally result in stronger storms, so hurricanes, typhoons, and cyclones, and more frequent storms. So many kind of tropical areas in the south have been experiencing these effects because as the ocean warms up, more water vapor is evaporating and getting into the atmosphere, and so you have warmer oceans, you have wetter air, and this means bigger downpours when that air is hitting land and condensing into rain. For instance, I'm sure all of us remember this, Hurricane Florence back in 2018. This was a record-breaking storm bringing heavy rainfall to the Carolinas, and here in New Jersey, we had our own famous hurricane, Hurricane Sandy, which many communities are still recovering from. Another type of storm that receives less attention but is just as dangerous are supercell storms. This is one in Glasgow, Montana. They are also dangerous because, as we all know, land can't always absorb all of the water that's falling. And when you do have more rain than the land can absorb, you have inland flooding and you have land and mudslides. Urbanization also makes this problem much worse because it clears trees, it clears permeable surfaces, and replaces them with impermeable surfaces such as asphalt and concrete. This means the land can absorb even less water than usual. New Jersey is one of the states, as an eastern state, that's set to receive many more heavy downpours and serious inland flooding. And as the most urbanized state in the nation, we actually are in danger of being very unprepared for this particular issue. On the flip side, climate change also results in more extreme drought. So really, we're not just getting more rain or less rain. Precipitation patterns are really just moving. So the same extra heat that is evaporating more water from the oceans and making those ocean atmospheres, the atmosphere above the ocean, more water heavy, is also evaporating more water from drier areas. And this water is being concentrated into specific areas, causing downpours and floods, and the areas that would have received that water normally don't, and they become much drier and have many more droughts. For instance, here is one in Sao Paulo, Brazil. Longer, more drastic droughts, such as the one seen here, are going to become more common and already are, as I'm sure anyone paying attention to the western United States right now in summer 2021 can see. This drought in 2015 to 2016 was a result of these changing precipitation patterns, as we are now seeing all across the world. Hand in hand with higher temperatures and more droughts also come wildfires. So areas that are already hot or already dry and have a history of experiencing fires just get hotter and drier and therefore essentially turn into kindling. So like with storms, where higher temperatures mean more storms and more powerful storms, higher temperatures generally mean more stronger wildfires, such as this one here in Fort McMurray, Canada. This destroyed large parts of the city and forced about 100,000 people out of their homes. Overall, we can see that extreme weather catastrophes are increasing across the globe. According to the insurance industry, these events have been increasing worldwide. Over $160 billion in losses was reported in 2018, and another $140 billion in 2019, putting these recent years among the top 10 years for disaster losses. So this doesn't just have a humanitarian cost, it has significant economic costs as well. However, climate change is not only manifesting in these ways that are very flashy and they often catch our headlines. They are also coming in ways that are a lot more permanent and a lot slower in ways we don't see as obviously. For instance, if you look at this photo of an unnamed glacier in southwest Greenland, this was taken years ago in 1935. And as you can see, the glacier's in pretty good shape. The whole fjord is filled with ice. Look at that same glacier much more recently, in 2013, and rising temperatures have almost completely melted it. And this is a pretty big glacier. Those are mountains right next to it. Yet that's just a fraction of the ice that has already melted and will be melting in the future. NASA has been keeping track of these decreasing ice levels, both in Greenland and also in Antarctica. Though in New Jersey, we don't necessarily think of glaciers as being a big deal, they do hold 2.1% of all of the water on Earth, which is 3/4 of all of the fresh water that we depend on. As they melt, they're taking these tons of water and dumping them into the ocean. This raises sea levels, and it also changes the patterns of our currents, such as the Gulf Stream, as suddenly water that was warmer and saltier is having dumped fresh, cold water, disrupting the way it moves with usual currents. When sea levels rise, storms are no longer needed for usual flooding. Sunny day flooding, as it's called, like this example in Miami, are becoming more frequent. So this was taken in 2015, but it has not disappeared since then. It has gotten much worse as sea levels continue to rise. High tides are able to very easily flood streets of cities like Miami that were built on coasts, often on former wetlands or floodplains, at or even below sea level. So even though a city like this may be able to recover from a single storm or single hurricane, you can't really recover from permanent sea level rise and flooding every time there's a regular high tide. Miami is actually the #1 city at risk in the world, considering the assets at risk it has from sea level rise, but it's not the only one by far. As you can see here, New York and our neighbor Newark, since they're classified together, is the 3rd city on this list for the entire globe. And though this date up here, 2070, may seem like it's very far away, sea level does not happen all at once. The damage has already begun, and it's going to get a lot worse before that 2070 date. So don't be fooled by that. Shifting from assets to population, you can see that many huge cities along the coasts of developing nations are at risk for going underwater as well. This means millions of people are going to lose their homes, their livelihoods, their communities, and in many cases, even their lives. These dispossessed people who are in cities and many other communities that center and cluster around the coasts are going to need to go somewhere, and it's going to create a climate refugee crisis as people run from rising sea levels, as well as many of the other more frequent disasters that we've already talked about. Because of this, via sea level rise and other natural disasters, the U.S. Department of Defense has said that climate change will likely lead to food and water shortages, pandemic disease, disputes over refugees, and natural disasters, as we have said, in regions across the globe. And this was said 7 years ago, so we have known this for quite a long time. It is not a surprise at all. Heat stress, coming back to that, does not only affect people, it also decreases the yields of crops such as soy, corn, rice, and other really staple crops. Rice, wheat, and soy also lose nutritional value when they're exposed to higher levels of carbon dioxide in the atmosphere. So literally, even though carbon dioxide is not a huge component of our atmosphere, it's not only increasing temperatures, but also hurting the nutritional value of our food. As populations grow, we need as productive agriculture and as much agriculture as possible to feed more and more people. But as we lose land to sea level rise, to salinization, desertification, and all of these natural disasters, that is essentially a food crisis in the making. Not only that, climate change needs to check off all the boxes for being terrible. So climate change is also a medical emergency because major health hazards such as infectious disease, heat stress, air pollution, and waterborne diseases all are exacerbated by climate change, rising temperatures, and all of the other situations as a result of it. If you look at this map here, you can see that tropical diseases that we usually consider to be pretty confined to the equator, right? We don't have to deal with them here. They're pretty rare here, are all moving away from the equator because rising temperatures mean that vectors such as mosquitoes and other insects are able to spread farther and they're able to survive longer. So you have longer ticking mosquito seasons, so more people every summer getting infected with these dangerous diseases. Climate change, of course, does not only affect people. We are not the only things living on this planet, and so we are now at risk of losing up to 50% of all land-based species in this century. And because of this, many scientists are saying that we may be in the middle of what they're calling a sixth mass extinction. A mass extinction is when we're at risk of 70% of all life on the planet dying out. So this is marine and terrestrial life, and this is serious. It has only happened 5 other times in our planet's history, usually because of very extreme changes happening around the globe. But because of these climate conditions, as well as other human activities that are destroying habitat and destroying natural processes species depend on, we are at risk of this major catastrophe that obviously will have impacts on us because we depend on other living things and ecosystems as well. Because of this and much, much more, the World Economic Forum has said that carbon is the #1 threat to the global economy because of the political instability it's going to cause, famine, infrastructure damages, etc., etc. So, must we change? Yes, definitely so. This leads to the next question, can we change? And though climate change is infamously a depressing topic, the answer to this question is actually pretty exciting because, for the most part, we do have the solutions we need at hand. For instance, if you look at how wind has grown over the past 2 decades, in 2000, the projection was that worldwide wind capacity would reach only 30 gigawatts by 2010. In reality, by 2019, that goal was exceeded by a factor of 22 times. In fact, if you look at how wind energy capacity has grown over the past 4 decades, it is practically an exponential curve. It has grown tremendously, and globally, wind could probably supply worldwide electricity consumption 40 times over. And though this is not likely to happen, it does demonstrate the practicality and the scalability of this single solution to our fossil fuel problem. Solar has experienced much the same trend, but even more drastically. So in 2002, the projection was that the solar energy market would grow 1 gigawatt per year by 2010. In reality, by 2010, that goal was exceeded by 17 times. And by 2019, it was exceeded by 122 times. So when you look to see how solar installations have increased over those same past 4 decades, it is an even more drastic and steep exponential curve than wind has experienced. Probably the greatest criticism, you could say, of solar is that solar is expensive, right? They say it costs more than fossil fuels, but that same exponential growth curve that you see in the increase in solar, you see going in the opposite direction in terms of the cost. So the cost of solar cell modules has really dropped to the point that solar is now cheaper than fossil fuel energy in some places. In fact, solar is actually providing energy to places that have never had full electrical power before. So the low initial cost of installing, say, some solar panels, a very small and localized grid, versus the cost of installing all the infrastructure that is associated with fossil fuel-based power means that many smaller and developing nations are able to totally leapfrog fossil fuels and simply go straight to solar, not necessarily because of climate concerns, but just because economically it makes a lot more sense for them. The Chilean solar market is a prime example of a market that is taking advantage of this fact. So you go from barely anything at the end of 2013 to 2.3 gigawatts by the end of 2018, and then totally dwarfing even what we had in 2018 and making not even visible on this chart what was originally there in 2013. Another 16.67 gigawatts of solar projects are expected to start providing Chile energy soon as they are approved or already under construction. Storage capacity is another big hang-up for people who are concerned about the plausibility of renewable energy, right? Because the sun is not always shining, the wind is not always blowing, so we need a way to store the electricity that we produce when those two renewable resources are not available. This makes storage capacity a really essential part of a future clean energy economy because we need it to store this power and also for electrical vehicles. Thankfully, capacity did almost double from 2018 to 2016, and then it is expected to by 2040, so just within under 2 decades, to again completely dwarf what we originally had back in 2011. So this is a incredibly good projection for the future of a clean energy economy. Not only is burning fossil fuels for electricity a very serious source of carbon dioxide, but so is the transportation sector, making it really essential that all of these companies have now offered to or committed to offering in the future electric vehicles. So you see plenty of big names here and traditional producers of fossil fuel-based cars that are now making commitments to even becoming fully electric within the coming decades, which is essential if we do want to have a fully green economy and society. Not only is burning fossil fuels, whether it be for cars or for electricity, a major source of carbon dioxide, but traditional farming is as well. Farming destroys carbon sinks when it clears forest and grassland to be able to, create those type of flat, featureless farms that you always see. And traditional farming practices such as tilling also destroy soil, releasing much of the carbon dioxide that soil is really great at storing. This all exacerbates climate issues like erosion problems as well as water loss, as soil becomes less effective at storing water during periods of low rainfall. Regenerative farming is meant to address many of these problems. It actually sequesters carbon rather than releasing it, and it maintains healthy soil and ecosystems in order to be climate resilient and resilient against all of these disasters. When you learn about regenerative farming, you see that there's 4 essential tenets. So first, sequester carbon, very important. Next, sustainably raise livestock. So avoid factory farming, which is incredibly bad, not just for the animals, but also for our climate and our environment. Focusing on conservation practices is that third pillar. And then finally, restoring soil health, which is essential for sequestering carbon dioxide and maintaining climate resilience. So you'll see practices like cover cropping, no-till agriculture, agroforestry, and other things that are all meant to both prevent and prepare for climate change. Another kind of naturally nature-focused solution is wetlands restoration. These projects are meant to reverse the tide of urbanization, to protect shoreline communities, and also sequester carbon. So the present-day normal is really to drain and fill wetlands in order to expand shoreline cities. This is a very harmful practice because, one, wetlands sequester lots of carbon. Wetlands and peatland soil store much more carbon than the average soils. Wetlands are also important barriers for flooding. They provide clean water and they filter out pollutants from the water, and they are also major wildlife havens. Also, when communities are built atop of these flood zones, usually it's low-income people of color who are being put into modern flood zones where they receive very little aid to recover from inevitable disaster, which is a very unjust way of building so-called affordable housing. Wetlands restoration projects, thankfully, are gaining attention and hopefully funding, and they will fight these things, all of these problems, and they're another solution to prevent climate change while at the same time preparing for the effects that we are already beginning to experience alongside for reforestation and other types of habitat restoration strategies. So, can we change? Again, the answer, thankfully, is yes. So we move on to the most important of all 3. Will we change? And in the case of teachers, will we be teaching to change? So many of you probably heard this in the news. This April 2021, if you're watching this later, President Joe Biden held a virtual Leaders Summit on Climate in which 40 world leaders came together to make commitments to combat the climate crisis. So it was a very important step. It showed the recommitment of the U.S. to climate action after 4 years of not really doing much at all. And it shows that climate change is a top priority for Biden, along with the rest of the world. All of these world leaders coming virtually to this climate-focused summit versus focusing on other things. Still, the last theme of the most recent global climate strike was no more empty summits for no reason. Largely, the summit was pretty disappointing. There were not too many new significant commitments, and the rest of the world showed that it does not trust Biden, and mainly the United States, yet enough to actually take action without seeing something drastic from us first. As it stands, nations around the world have made a host of different climate commitments. So here's some examples. U.S. commitments that Biden announced was a 50% reduction from 2005 levels of emissions by 2030. China has promised to peak emissions in 2030 and be carbon neutral by 2060. Canada has promised a 40 to 45% reduction. The EU is the most aggressive so far in its promise with a 55% reduction. India has promised to build 250 gigawatts of renewable energy in their country by 2030, and Japan has promised a 46% reduction. So some of these promises are pretty good, and they are better than nothing, but still, most of these countries aren't doing so well in actually approaching fulfilling these promises. As you can see on this map, the US is critically insufficient. If every country behaved like the US was, we would be on track for a world with 44 degrees of warming or more. Even countries that are doing slightly better are still not too great. So you can see here that China and Japan are both highly insufficient. Canada and Europe are all mostly still in orange. They're insufficient, and the only country out of all the ones that I just listed was India to even reach compatibility, not with the 1.5 degree goal, but with the less ambitious 2 degrees Celsius goal. So none of really the only countries that are even being compatible with the Paris Agreement are these two here, and there are no countries fully in that dark green, that role model zone. So even though all these promises have been made, there is a lot of progress to be done in terms of actual action. However, public opinion is shifting in favor of more climate action. So the majority of Americans do say that the federal government is not doing enough to protect the climate. 60% of Americans think that the federal government is doing too little to combat climate change. And even though there is still a huge partisan split, so 90% of Democrats versus only 39% of Republicans, the majority of moderates as well as younger Republicans also do believe that we need to be doing more to combat climate change. So that is a good sign. If you look here, the partisan split over the impact of human activity on climate change, even though it is not great, it is also not consistently in the minority. So if you consider a great deal, and some, only 19% believe not at all. And even if you look at Republicans and conservatives who generally think less about human impact on climate change, still with a no category is in the minority. So again, that is something. The majority of US adults also say that climate change is affecting their local community. So 62% of American voting citizens are saying that they're seeing climate change around their own homes and it is affecting them personally, which is very important for people to recognize because it makes them a lot more likely to want change. The majority of Americans, not necessarily regarding climate change in particular, are also saying that they are taking actions in their personal lives to help protect the environment. And though, yes, climate change is a systemic issue, it does not rest on the shoulders of the individual to solve climate change all on their own. We do need individual changes in our livelihoods. So this is, again, another important step. And of course, my generation, Generation Z, is continuing to demand action, even though with COVID-19, we can't gather in crowds such as this, like we did in 2017. All of these people are still out there, and we are still demanding more action than we have been seeing. Kind of zooming in on New Jersey in particular, in 2020, New Jersey became the very first state in the nation. So this is a big step to mandate that climate be taught in every class. K through 12, every subject that was updated that year, which is everything but math and English, which were not updated then and will be updated in a later year, presumably with this receiving the same treatment in terms of climate change that all of the other subjects did. This is thanks to First Lady Tammy Murphy, who really made this a priority. So now you can see in the NGSLS for the sections of all of these subjects, this standards and action climate change section. So encourage you to go check that out on the NGSLS website. And you can also see other new requirements regarding climate change throughout the learning standards for all of these subjects. This is great because it demands that everyone, all the way from kindergarten to their senior year of high school, are learning about climate change. They're building on what they already know, and they're taught it in an interdisciplinary way, right? They're not only learning about it in science class, they're learning about how it engages people in social studies, how they can address it in their art. They're learning about it in their health classes, and it really shows them that climate change does intersect with most areas of our lives, and no matter what they're interested in, they can take steps for climate action, whether or not they're into science or into politics or something like that. So yes, it is a big challenge. The deadline for the implementation of this is 2022, which on top of everything else our teachers have been facing since the COVID-19 pandemic started is a lot to put on their shoulders, but it is also a very big step forward and is why we need to support our teachers and why we have made this website our mission. So, will we change? Really, that is our choice, and at this point, honestly, we can't tell. I wish we could, but we can. So really, we need people like you to join those who are using their voices, their votes, and their choices to fight the climate crisis. And if you're a teacher, which I assume you are as you are watching this video, we need you to join others across the world and bring climate into your classroom. If you are looking for organizations or resources to help you do this, the Climate Reality Project, our New Jersey chapter, is the Greater New Jersey Gateway chapter, has plenty of resources to help you. So you can take the national or international training to become a climate reality leader. You can take it virtually from your own home. I and many other young people and other teachers have been able to do this, which is really great if you want to learn more about how you specifically can take part in the climate action movement. But also, if you aren't ready for something that ambitious, you can join our chapter's teacher workshops really focusing on climate change and environmental education, and you can get professional development credit. And of course, there is our website based on many climate reality resources and things we've learned in these different trainings to help you navigate through this, even if you don't have time for any of that training type thing. The New Jersey Student Sustainability Coalition is also a great organization. I'm a part of it on that leadership team, and there it's great because you can have student activists come into your classroom and give presentations. I've done some of these. Other members of our coalition, which is I think over 300 people across New Jersey, mostly high school and college students, have done this, and it's a really great way to show your students what real life climate action work looks like and show them that other people just like them are working on this. And it's also a great place to refer students who are interested in doing more. So if they want to take what you taught them in the classroom and implement it in real life or be involved in some other way, NJSSC is a great place to start where they can get training and where they can meet other young people like them. The Alliance for New Jersey Environmental Education is also really great for teachers. They have a lot of resources, great webinars and lectures and workshops about environmental as well as more climate-specific education. So I've been to some of their events, and they're really great, and I would recommend that if you are feeling lost or would like to connect to other teachers who have a little bit more experience with teaching climate change. So please use your voice, your vote, your choices, and above all, your classroom to speak truth to power like your world depends on it, because truly it does. Thank you very much for listening. To learn more, you can obviously go to the Google site, whether you're seeing this on the website or on our YouTube channel. There are many more resources there, and we encourage you to explore that, especially as we update it, because it is a live website. It is not nearly complete, and we will continue to add more pages and more types of resources as we grow. You can also contact us on the Google form on the homepage of that website or at this email right here, crouth@gmail.com. If you have questions that you would like to see answered on the website, topics that you want us to add, or other comments, questions, or concerns regarding the website or the Climate Reality Project chapter. And for more information about Climate Reality and an organization as a whole, you can look here, climaterealityproject.org, at our national website.